Okay, so today we're going to talk a little bit about crash data. I would assume that both of you have at least some degree of familiarity with the Michigan UD10 crash report form. We'll talk a little bit about that, about how we use crash data. And then I also had some ideas in terms of the course project that I was going to have you guys work on the side. So there were I became aware of some changes to some of the national data sources that are useful for safety analyses. And so I think what I'm going to have you do is start to review some of those materials and prepare some curriculum content on those two systems. And I'll talk about that a little bit more probably on a subsequent lecture. But anyway, so we'll talk a little bit about crash data collection, the crash report form. I'm sure you have some experience with collision diagrams from prior classes, and then some of the available resources we have to work with. And so from our perspective as engineers, there are several different ways that we would approach safety, whether this is from a reactive or a proactive standpoint. But basically, we're looking to reduce the frequency or rate of traffic crashes, and there's various ways that we can attempt to do that. We can try to minimize the potential for traffic conflicts at various locations. We can ensure that the road, meets some of those nominal roadway design standards that we've talked about in the past. And then in addition to reducing the frequency or rate, we're also interested in reducing the severity of crashes. So when a crash does occur, there are ways that we can minimize the likelihood that those crashes would result in severe or fatal injury. And so that would include different types of safety devices like cable median barrier, or any type of barrier system, basically crash cushions, different features that mitigate the severity of a crash when they do occur. And a few other similar examples would be like roadside design, trying to ensure we've got sufficient clear zone and some of those other issues. And then there are also certain subsets of crashes that we'd have a particular interest in, either because they result in a disproportionate number of fatalities or they're particularly challenging to address. And so some of the examples there are alcohol involved crashes. And so I think we talked about this statistic last week, but if we could just eliminate all DUI involved crashes, that's roughly 10,000 fatals a year, or nearly 25% of the national total. Likewise, speeding continues to be a huge issue nationally. There's a recent report that was released, or a series of national reports that have kind of documented the contributions of speeding to crashes and the increase in fatalities we've experienced even over the course of the pandemic. And with that being said, despite the fact that evidence pretty consistently shows that higher speeds are a problem, states continue to increase their limits, as an example. And then older drivers continue to be kind of a unique issue because our population of drivers is aging at a rate that hasn't really been seen in some time. And with that, those drivers tend to be overrepresented in crashes once they get to certain age ranges. And so it'll be interesting to see potential solutions for some of those issues as well. So those are just a few of the different contexts from which we're interested in safety from a transportation engineering standpoint. And so in terms of how we can actually impact any of those metrics, so you've probably seen before, there's basically three primary elements that contribute to crash occurrence. So there's three involved entities or parties, and that would include the driver of the vehicle, the condition of the driver, physically, mentally, etc. That driver's baseline level of training, their knowledge of rules of the road, their technical driving skills. And so obviously all of those play different roles. Driver's state or condition, so whether they're impaired by alcohol or drugs, whether they're distracted by anything inside or outside of the vehicle. And then the vehicle itself, I would say, is somewhat of a lesser contributor, generally speaking, to crashes. But if you have a flat tire or some other issue related to your vehicle, you've got blind spots and things of that nature. There are various ways that vehicles can contribute, and to that end, that we've seen a lot of advances over the last really 5 to 10 years, specifically in terms of some of the automated technologies. I don't know if either of you have any of the lane departure warning systems or forward collision warning systems in your vehicle. Either of you? Okay, I can tell who has the better vehicle among the two of you, possibly. But yeah, so I've got. No, I take it back. I don't think we have that. I had a GMC Terrain that was a 2015 where we had some of the earlier rollouts of the lane departure and the collision warning. And the collision warning still had a bit of development work, I would say. There would be certain sections of road where I'd drive over that road every day, and every time it would think that there was something that the vehicle needed to decelerate for, even though that wasn't there. And so we're seeing a lot of advances in terms of those technologies. If you look at any 2020 or 2021 vehicles, that's improved quite a bit. The lane departure stuff, you can tailor the sensitivity of those systems. So on that same vehicle, I would be sure to turn that down a bit because you'd have a lot of false alarm type warnings and things of that nature. But anyway, there is quite a bit of potential there. We'll talk a little bit as we go through the semester about the functionality of some of those advanced driving assistance systems, or ADAS is how we refer to those. And so I guess the vehicle is playing a much larger role now than it has in the past in many respects from a safety standpoint. And then thirdly, the roadway environment itself. And to my preceding points, there are ways that we can design that roadway environment to either reduce the likelihood that a crash is going to occur, or if a crash is going to occur, try to make the roadway and the adjacent environment crash worthy so that those collisions are less likely to result in more severe consequences ultimately. Okay. Now, from our perspective as engineers, where do we have influence among these three different elements?
The roadway.
Yeah, roadway is really the only place where we would have substantive influence, I would argue. I mean, there are some manners in which we have control, and I'll use that term very loosely, over the driver, but how can we as traffic engineers influence the driver? Any thoughts on that?
I mean, I would say like designing the roadway to a as safe as possible manner to not give the driver a chance to make a dangerous action or something like that.
Yeah, so in part, we're anytime these crashes occur, it's basically an error, more likely a series of errors or consequences. And so we basically try to build in a significant factor of safety. And so to that end, we'll talk a little bit about that in the design piece as well. A lot of that's more kind of on the roadway side. And so we're not necessarily influencing driver behavior per se, but we're recognizing the limitations of driver behavior or the nature and proclivity for drivers to make errors. And as a consequence of that, there are certain ways that we can try to dummy proof the system. But, as we saw in the statistics last week, we still have anywhere from 6 to 13 million crashes and nearly 40,000 fatalities per year. So, but I would argue we have at least some influence over the driver, with the primary element there just being, the use of traffic control devices of various types. So things like roadside dynamic message signs, and that's, I think you said in some of those presentations we had last semester, we're trying to evaluate whether those have any meaningful impact on driver behavior. And it looks like they probably do for things like keeping drivers aware of travel time and things of that nature, but the evidence has been more mixed with respect to some of those safety messaging strategies that have emerged recently. Just the design of signs and pavement markings and those different visual cues we provide to the driver. are probably good examples. And you might be aware, so they're currently accepting comments on the next edition on the Manual of Uniform Traffic Control Devices. So I've not seen specific details of a lot of the changes there, but I know they have, I want to say, hundreds of pages of content that is undergoing some form of revision there. And so, for example, some of these devices and the studies that you have been involved in, so the driver assistance devices will still remain experimental in the near term, and there are a few other types of emerging traffic control treatments like that. They've introduced some additional guidance for specific treatments. Like, are you guys familiar with pedestrian hybrid beacons or hawk signals? I'm trying to think. Do they have any of those installed in the Lansing area?
There's like something similar to it on Lake Lansing, like a mid-block signal, but that might just be a full signal if I'm thinking
Okay.
right.
So in any case, it sounds like you guys are at least somewhat familiar with those. So when they were first introduced, and we had one, two, I want to say three on the Wayne State campus, at least two. My memory's a bit hazy there, but when we first put them up, like, drivers had absolutely no idea what to do with them. Because you basically treat them, it's not quite a traffic signal, you treat it as a stop sign. When you treat it as a traffic signal when it's solid red, and then you treat it like a stop sign, where if there's a pedestrian in front of you, you stop for them. Otherwise, you stop and continue through when it's flashing red. But given the relative novelty of that, those are some ways that we can try to influence driver behavior. But if drivers don't understand what those cues mean, that's a problem. And so if you look at the evolution of traffic signs, and I don't know the extent to which you might have noticed this in your own driving experience, but we're going to symbols that are generally a lot more symbol based as opposed to word based. And there's several reasons for that, but part of it relates back to driver comprehension. On the vehicle side, we don't really, I can't think of any clear examples where we'd have control over the vehicles per se, outside of states like California, and there's a few other states where they have, I guess, Jordan, you're coming from that area, where they'll have periodic vehicle inspections and things of that nature. And there's more rigorous oversight for large trucks, I guess, would probably be the best example nationally, where you'll have certain requirements in terms of weight and tire tread and other criteria that have to be met for long haul trucking, that we don't see those same levels of requirements for personal vehicles. So anyway, most of our influence then comes in at the roadway level. And to that end, to my prior point there, so part of it is influencing our ability for the driver to maintain control of their vehicle as they're navigating the roadway. And so there's various ways that comes into play. So things like lane width, we have relatively good ideas about how varying cross-sectional characteristics affect both operational and safety performance, generally speaking. So typically wider lanes are safer, although the research says anything beyond 12 feet and particularly above 14 starts to get a little bit too wide, and you'll have probably another more California type problem where you have people sharing a lane, for example, if you make them too wide. Likewise, alignment, obviously a lot of that relates back to the AASHTO Green Book. And so we have, the minimum physics that we need to satisfy, and then related to that, the stopping sight distance, intersection sight distance, passing sight distance, etc. The pavement surface, to a degree as well, specifically at some of the high-risk locations like horizontal curves, you'll see a lot of friction treatments that are being applied at locations where we have a history of problems there. But across most of these different design criteria and design elements, we are basically trying to provide, I guess, to the prior point we had brought up, enough factor of safety there that we can, even when errors do occur, They don't lead to crashes very frequently, so we'll tend to have a lot more near misses that occur than actual measurable crashes, as we talked a little bit about last week as well. Um, and then outside of those elements, traffic conflicts, particularly as we get into more urban areas, are the biggest problem areas. So anytime you've got traffic streams that are crossing one another, that's when we tend to run into some of these issues. And so as we get into some of these urbanized areas, we talk a lot about access control. So, the use of medians and different other types of channelizing devices that would try to either discourage or prohibit certain types of maneuvers. Um, Intersection design. So you might be aware we were just awarded a roundabout evaluation project. And so we'll be doing some field studies and some crash analyses there where we'll be comparing roundabouts to other types of, say, signalized and two-way and always stop controlled intersections. And so as opposed to, I don't know, maybe 15, 20 years ago, a lot of those intersection design projects were almost universally focused on traffic operations, with safety more of a secondary measure. But particularly with the highway safety manual and with the introduction of roundabouts at relatively large scale, we see safety become a more explicit consideration for intersection design. Railroad crossings have been an issue since, the initial transportation legislation that had introduced some of the rail grade crossing programs and things of that nature. And so we saw pretty dramatic declines in railroad involved crashes in the 90s into the early 2000s, and a lot of that's largely plateaued since then. Because if you look at where these crashes occur, has anyone ever been in a difficult situation near a railroad crossing? We're from a very rural part of Upper Michigan, and I can think of at least one occasion where I was with a driver that wasn't paying a lot of attention near a rural, just passive control. There's just a crossbuck basically. And have you guys seen the movie Stand By Me? I'm really dating myself here. I'll also disregard them. But I basically was yelling train at my driver there. So, but that's where a lot of those crashes tend to occur at rail grade crossings. You see a lot of coverage of violations, like even on the MSU campus, we've got a few, grade crossings where people have to wait quite a while for trains. And so you see people moving around the gates and everything. But a lot of times you'll see the bigger risks are at these locations that don't necessarily have some of those treatments in the very rural areas. So that has continued to be a large problem, in part because it's expensive and generally not worth the investment to put in the more active types of warning devices like gates and things of that nature. And so we're left with these more passive devices where you rely on drivers to be paying attention and so forth. Traffic control devices. So in this area, there's been a lot of emphasis in areas like wrong way driving is where they've been trying a lot of interesting treatments recently. Like you'll see things like either lights or pavement markings that will look different depending upon which direction you're traveling on the pavement. I don't know if you guys have seen any of that experimental work or not, but those are some pretty cool devices. There's a lot of things that can be done with cameras and sensors these days as well to try to identify when some of those risks are elevated in near real time. And then so those first two categories are really circumstances where we're trying to just prevent crashes from occurring. And then, as I've talked about previously, when the crashes do occur and the vehicle leaves the roadway, we've got different types of concerns that we would deal with in those circumstances. So ideally, wider shoulders, more accommodating cross slopes so that they're recoverable, or at least traversable, for example. Minimizing fixed objects near the roadway, using barriers, crash cuts, cushions, other types of devices. And then to a lesser degree, affecting the behavior and attentiveness of the driver. There's a few specific examples here. So the driver's choice of speed and path is something over which, we have some degree of influence. And I'm thinking specifically about cases like work zones, for example, um, or I guess anywhere we're trying to identify ways to reduce travel speeds, can be a bit of a challenge, because generally speaking, the speed limit has some influence, but largely speaking, drivers just kind of adapt to the nature of that environment. So anyway, so those are the different ways we can try to look at addressing safety from an engineering perspective. But beyond that, we're ultimately interested in trying to assess performance, both in real time and then, moving forward over time as we look at where projects are potentially warranted. And so the way we make that determination historically for any safety improvements, it's going to be on the basis of crash data by and large. Have either of you been involved in any traffic crashes incidentally? Oh, wow. Excellent. So I've been involved in, I'm trying to think, a few very minor, well, my first crash I was involved in was in the summer of 1998, I think. I tried tracking down the crash report at one time when I was at Wayne State. Now this was, I guess, 8 years after it had happened. But have either of you driven US 41 between Negaunee and Marquette? Okay, so basically driving towards Marquette, I was a passenger. My uncle was in a pickup truck, and a deer ran in front of us, and so we swerved to avoid the deer. We rolled the truck, and he wasn't wearing a seatbelt, and so we rolled, and I came to, and he wasn't in the vehicle, and it was flipping crazy. He ended up fracturing vertebrae in his neck and had to be in a halo, and fortunately he ended up being all right. But that was pretty crazy. And you see on the dynamic message signs, they would show those generic "don't veer for deer" messages, but that is, sound advice from that case. And then I think the other crash I was involved in, which I think was maybe the following summer, 1999, we were coming back from a Milwaukee Brewers game. Why a Brewers game? Because that's actually the closest professional sports, no, outside of the Green Bay Packers, I guess. It's the closest baseball stadium to the Upper Peninsula. And so in that case, we had borrowed a van from a friend, and one of the drivers in that case again veered to avoid a deer, and we almost rolled that, but we ended up on the roadside there. I think all my other examples are very minor. I got rear-ended in a Taco Bell parking lot, and the guy ended up covering my tab or giving me extra tacos, I think. And then I was also rear-ended at a traffic signal, and it was just a small bump, and so no damage, and so we just drove away and didn't report that one, for example. But usually, depending in larger classes, we'll have a few other interesting stories.
For the record, I was actually in a very minor accident with Travis coming back from the trip where we drove between Negaunee and Marquette. We got in a small fender bender by the Meyer and the Taco Bell down Grand River, and I thought that I crippled this lady, but it turned out that she just already walked with a limp.
Oh, geez.
But yeah, that was my only minor collision.
Interesting. Yeah, because if you look at the statistics, the odds of being involved in a crash at any point are fairly high. Just given how frequently those types of minor incidents would occur, as an example. But anyway, as we look at those crash reports, so there's basically two different ways that those are filled out, either by an officer on the scene or from self-report. After the fact, the public can report those crashes. And generally speaking, there are criteria in terms of what gets reported, and those are generally based upon what happens, whether there are injuries sustained by the occupants of the vehicle. So virtually every state, if someone's injured, the state would track that data. Excuse me. For non-injury crashes, property damage only, those would tend to vary quite a bit from state to state. I know for the longest time, the state of Illinois wouldn't collect any information on non-injury crashes, and that's just one nearby Midwestern state that I was familiar with. And that was always surprising to me because Illinois experiences quite a few crashes if you think about Chicago and the greater metro area there. And so there's a lot of information that's potentially lost there, but at the same time, it's non-trivial the amount of resources that need to be invested in some of these crash data systems as well. So here in Michigan, the current limit is minimum of $1,500 in property damage or an injury by one of the vehicle occupants or what would trigger a crash report form. And that's pretty typical if we look nationally. A lot of states are in that $1,000 to $1,500 range. Now, those are, there are certainly crashes that get reported below those thresholds. And the officer's not going to audit what the actual dollar amount damage is, so they're just ballparking in a lot of cases there. But as we saw last week, still nearly half of all crashes aren't reported, and a lot of those it's because the crash isn't serious enough for it to be reported. And then there's other subsets where the crashes are reported and it just they're I remember in Iowa they would, I don't know how they did this, they would assign officers would, I guess, give estimates of the dollar value of the cost to the damage to the vehicle, and I was never quite sure how they did that, because if you think about just make and model, there's so much variability in terms of what those costs would look like. But anyway, I don't want to go on a huge tangent here. One of the big advances I've seen just from when I started in academia back in 2006 or so, I want to say around that time, it was maybe 10 to 15% of crashes were electronically reported, maybe. And now the vast majority, and we can actually probably check this on Crash Facts, have gone electronic. So a lot of those systems were introduced in the vehicle in the early 2000s, the mid 2000s, 2005, 2010, that range. A lot of states started going in that direction. And that provides several advantages. We get significantly more accurate and precise data as to the location of those crashes. It's a lot easier for us to do QA/QC reviews. So a lot of times in the past, if there were discrepancies, between fields in the crash report form, there was some quality control review that went on after the fact. So crashes that weren't locatable, for example, they would have staff at state police that would assist with that. But any errors or inconsistencies, and you'd find numerous examples. You can probably still find those in many cases. We'll work with different fields from the crash report form, and you don't necessarily see consistent information. Sometimes things are left blank or not filled out, or they're filled out in contrast to another field. But a lot of that has been minimized with some of these electronic systems because they can build those fail safes directly into the crash reports, basically. And so if you enter conflicting information, at least for critical fields, that can be flagged ultimately. And so these databases, so the crashes are generally reported centrally to, for example, here, the Michigan State Police would maintain all those crash reports, and they're housed within similar either criminal justice institutes or state patrol agencies in different states. In some areas, and Iowa would be an example of this, it's actually collected and maintained the repository by the Department of Transportation. And then even here in Michigan, though state police is the one that's responsible for collecting and maintaining the crash data over time, they obviously share that with various partner agencies, including MDOT and others. And so depending upon the state, there are significant differences, though, in terms of how those data are ultimately made available. So Michigan has one of the better systems because virtually, anyone that has an interest can get free access to anything except for personal identifying information for any and all crashes, right? So you can use the Michigan Traffic Crash Facts data query tool. Have both of you guys use that to some degree at this point? Okay. I'll a little bit, it looks like. So I'll get you guys a little bit of exposure to that as well here in the near term. And so that's a great resource because prior to that, and that site's been around since, oh gosh, probably 2004, 2006, sometime in that range. I know the data goes all the way back to '04 at this point. And a lot of other states have started going in that direction as well. So Iowa had just made a public facing system my last couple of years there, so maybe around 2015, 2016. California has made their data publicly available for a long time. And then there's a number of other states where that's not the case. So I did grad school at Purdue, and in that case, the crash data was housed at the Indiana Criminal Justice Institute. And I think there were certain mechanisms wherein you could get access to some of those data for research purposes. But I know we had some studies where if we wanted the data, they were quoting us $3 per crash report form. And so if we wanted to do a study of 100,000 crashes, you'd have to come up with $300,000, which was really quite a barrier. And I would presume that they've addressed some of those issues since, but in part, it's somewhat of a moneymaker. And one of the reasons, and we'll talk about this on one of the subsequent slides, why you would not just provide them totally free is that lawyers have a propensity for using that as leads on potential lawsuits and cases. And at least that's sort of what has always been stated anecdotally. I don't know how much credence there is to that. And obviously we haven't really seen, I don't think, any big issues here in Michigan or other states where that's all open. But there are other states that simply don't have the level of resources that have led to the development of these types of systems. So if you look at a lot of the rural states out west, they simply don't have as robust of safety data systems, in part because the population is not really large and it's relatively resource intensive to pull some of this information together. So now the purpose of the crash report form, there are various reasons this information is collected. Obviously, it helps to aid the engineering community. It provides insights for law enforcement as well, so we can identify where there are patterns of alcohol involved crashes or speeding involved crashes, things of that nature, so that can help to target enforcement campaigns. Likewise, locations that are prone to non-use of seatbelts and so forth. And then we can also identify just general types of trends using those data, which could be informative for education or training purposes or those various other stakeholders as well. So if we think about what's included on the crash report form, so what types of information would be useful to us or any other interested parties? Any thoughts as we think about what information shows up on a crash report?
Just types of vehicles, location.
Okay, so type of vehicle. Why is type of vehicle important?
I guess to distinguish between like the rates at which different types of vehicles, I guess for data understanding.
Yeah, so the types of vehicles, I think there's several different aspects from which that could be useful to us. One would be if we look at just general crash injury fatality trends, things of that nature. So that's something that like NHTSA, as an example, would track very closely. And as you're probably aware, so NHTSA has those 5-star safety ratings that they assign to vehicles, which are largely based on laboratory type tests. But NHTSA also, and this is one of the data systems that I'm going to look for us to focus on over the semester for the project I had alluded to previously. But we can generally get fairly good details. Like crash reports, they even collect things like VIN numbers, so you could get really accurate information about the features that are installed on those vehicles, as an example. And so things like field evaluations of some of those driver assistance systems is one example. So the forward collision warning I talked about previously, there's been some work that's been done by the Insurance Institute for Highway Safety that's estimated, pretty substantial reductions. I want to see in the magnitude of 40% in rear end crashes that have those systems installed as compared to other vehicles. So we can look at those types of things. We can look at patterns of injuries of occupants in those vehicles. And so like that's the type of information. One of probably the most recent large scale changes to the way crash data has been collected. And I forget when this happened. It must have been back around maybe 2011, 2012. The state had strengthened its booster seat laws. And in parallel with that, one of the big challenges historically in trying to evaluate whether or not those types of laws are effective is that a lot of times on the crash report form, I don't even know if a booster seat was included in those earlier editions. So it would just say that the child's belted. And so it was very challenging to try to evaluate the effectiveness of those programs. And then another concern is that generally what's happened historically is that data only needed to be collected for the crash involved driver as well as any injured occupants. And so we didn't collect information on uninjured occupants. And so that potentially loses some useful information about, reasons for why certain individuals were less severely injured than others, as an example. And so in parallel with those child restraint laws changing, they also began collecting information. And I don't know, I would have to double check what the actual policy is here, if they collected for all child passengers. And that might be the case, in large part just in support of evaluating progress towards some of those different measures. So sorry, that was a very long tangent there, Travis, as to why vehicle type is useful. But beyond that, what was the second item you had mentioned? I think location, which is probably one of the more obvious ones. Why is location important, Travis?
So we can track where accidents are likely to occur.
Yeah, right. So from a big picture perspective, that helps us in trying to identify locations that may be prone to an overrepresentation of crashes or injuries or fatalities. And we can use that as input in determining where safety improvements are necessary. That also helps us to integrate the crash information with roadway data so we can look at patterns across similar types of locations. So even if a site hasn't experienced the significant number of crashes over time, it may have different design characteristics that would put it at higher risk for crashes. And it's just for whatever reason, those crashes haven't been experienced. And so that's an area where it's been particularly important. But yeah, location is probably one of the bigger ones that's of value specifically to the engineering community. What else on the crash report form is useful to us?
Weather conditions.
Why are weather conditions useful to us, or how?
Yes, because the assumption is that in adverse weather that more accidents are likely to occur, but then we'd actually be able to track that.
Yeah, and it's really interesting to try to look at the effects of weather. It's much less straightforward than you might think at first. A lot of the work that I've done has shown that crashes go down and or injury severity goes down under adverse weather. Now there's a reason for that. In part, people are altering the way they drive as a consequence of that. So it's not really an apples to apples comparison there. So people are driving slower or more cautiously or with greater attention, for example, they may be involved in fewer crashes as a consequence of that. Now, from an engineering perspective, it's a little bit more challenging. So just trying to think about how you would make use of that weather information. Part of it, you could identify trends in combination with the location data in terms of where adverse weather crashes are occurring. So, I mean, maybe you could look at changes to maintenance policies and, salting and things of that nature. I guess another area that information is also useful because sometimes I mean, it might even make sense to exclude those from some of your analyses, because if you're looking at crashes under adverse weather, that may not have any direct relationship with any of the roadway specific elements. So sometimes, it could point us to actionable solutions, and then sometimes there's just crashes we'd want to be able to weed out as well, because they're somewhat, either tangential or completely unrelated to what our potential solutions would be. And I think one example there, what's the most frequent type of crash we would see in Michigan? I think this is an accurate statement the way I'm setting this up. And these crashes, generally speaking, there's not a lot we can do about them from an engineering perspective.
It'd be deer.
Yeah, deer.
Yeah, so I'm trying to remember when I last looked at it, we were seeing 60 to 65,000 at least of those per year, and those are just reported crashes. So if you include the ones that aren't reported, it's got to be north of 100,000, I would presume. But from an analysis standpoint, oftentimes we'll just kind of throw those out, because there's really there've been several studies that have looked at deer crossing signs and things of that nature, and by and large those results are largely mixed. They typically there's not compelling evidence that you're getting the bang for the buck there. But when we look at trends and patterns, generally speaking, those aren't going to provide us a lot of useful information. It's more or less kind of a shotgun blast in terms of when and where those occur largely. Now, with that being said, there are areas where you have much greater deer populations, and you could probably make an argument that they might make sense. They might have some small measurable impact on driver behavior in those circumstances. But okay, do we start weather? Is that how we started on that tangent? Okay, we might not get through the slides at this rate, so I'll start to click through a few of these, and we can comment on a few of these. So the location information, in addition, date and time information, why would that be important? So why are we interested in when the crash occurs?
I mean, I could see why time could be important if it's like late at night or early in the morning, or it's like a peak hour crash or something.
Yeah, so a lot of that we could relate back to just general differences in travel patterns during certain times of day, rush hour versus off-peak traffic. Certain types of crashes would be overrepresented at nighttime. We'd capture that same information with the lighting condition information there. And then again, the weather and pavement, like I said, that, maybe you could use that information to identify where you may have drainage issues and things of that nature, but those crashes are going to be relatively infrequent. The driver information is important to us for various reasons. So what type of driver information would we be interested in?
Age.
Yeah, age is going to be a big one. And there's various reasons for that, back to the point previously about just crash risk. And we generally see like a U-shaped curve where the crash risks are highest for the youngest and the oldest drivers for different reasons. In some states, we can get more detailed information, and like the Secretary of State data would be directly integrated with the DOT or the Michigan State Police information. So if you knew details of the driver's, training history, when they've had citations, suspensions to the licenses, some of that type of information. Now, we collect that information on the crash report form, but it's not part of an integrated system. So in concept, it would be feasible for us to try to investigate certain individuals that have received citations or had their license suspended and things of that nature, but would have to jump through quite a few hoops to get access to that in consideration of privacy information and things of that nature. So I think age is probably, like I said, the biggest example there. Whether they have specific licenses or endorsements, etc. The injury and fatality information, obviously we're more concerned from our perspective with the more severe crashes. And so Those are important to us. Likewise, the type of crash that occurs. So we'll talk a little bit about pattern analysis and some of the different types of countermeasures that can be used to reduce the frequency of crashes. One of the most valuable pieces of information historically has been the diagram and narrative section of the crash report. And that's something where the one of the things that hasn't been quite as good, I would argue, broadly, with the transition to electronic crash reports, is that sometimes they won't include a diagram as an example, whereas on the old paper-based forms, and this, I guess I don't have any data that reinforces this necessarily, but it seemed like there was more complete information on the paper-based forms in the diagram section specifically. With that being said, they have built in some really cool functionality that makes preparing the diagrams easier. And they'll have like icons you can easily drop in, and different tools, just laptop based in the patrol vehicles that they can use there. But that's an area where it's been somewhat hit or miss, because we used to be able to reliably look at the narratives to get better insights, and also to serve as a quality control measure to check some of the other fields. Because occasionally we'll run into circumstances where the officer doesn't code the crash correctly as it should be based on the manual. And so if you've got a good diagram or narrative that describes the crash, like for example, trying to distinguish between an angle crash and a left turn head-on crash, those vehicles could end up colliding at a similar angle, but the causative factors are going to be markedly different in those cases, right? Or so running a red light versus looking for a gap in traffic in the opposing direction. You'd think of different countermeasures there. And so those are a few of the potential limitations. Now, there are some other fields on the crash report form that we'll talk about that can serve as proxies or control checks there as well. But and then the question of who relies on the crash report. So we've talked about a lot of these previously. From an insurance company standpoint, they're primarily concerned with this just from a financial perspective. So it's opportunities for clients, for example. Department of Motor Vehicles or bureaus of motor vehicles or Secretary of State here in Michigan. So, they do have a fairly well integrated system at the Secretary of State that tracks information on crashes and speeding tickets and other information that's reported. Likewise, those insurance companies track that same information, and it's probably an interesting debate in terms of who would have better data there. I would think maybe the insurance companies might even in many cases have better data available to them than the DMV, because from their perspective, insurance companies are interested in the reports for several reasons. Part of it is, from a lawsuit perspective, but there are tort liability limits and things of that nature. But the other context from which why else would insurance companies be interested in what they see in crash data? I don't know if any of you know are you familiar with the actuarial sciences?
I mean, they could probably adjust rates based on locations, ages, gender, stuff like that.
Yeah. So those are the big ones. So they basically can develop very sophisticated risk profiles, and the drivers who are more likely to be crash involved, charge them higher rates and so forth. And so that's the other aspect where, and there are organizations like the Insurance Institute for Highway Safety that kind of partner with different auto manufacturers and different insurance companies to try to provide those types of data. And again, they provide useful insights as to high-risk drivers as well as high-risk geographic areas where crashes are more likely and other crimes are more likely, and so forth and so on. Obviously, engineers are going to use this for the purposes of highway safety improvement programs, law enforcement. To a degree, they can use this to determine where it may make sense to conduct targeted enforcement. And then at the federal level, both the FHWA and NHTSA would be interested in this information for various purposes. So the feds, the FHWA would be interested in this just from a performance monitoring and measuring standpoint. Tracking progress towards the goals outlined in the highway safety plans that have been implemented in these states. NHTSA would be interested in some of these information when we look at things like vehicle recalls. So some of that information can be captured from police report forms. And then lawmaking as well, when we look at laws related to drunk driving, or, back when we had national maximum speed limits and things of that nature, a lot of that was driven by crash data largely. And then from a research standpoint, obviously, we use a lot of police crash reports in our own research to try to determine where we may be able to influence crashes through different types of design policies or programs or specific countermeasures. Okay. And so this is just an example from Iowa here, but there are a whole range of different partners who would use the crash data for different aspects of improving safety ultimately. Okay. So it's ultimately a cyclical program. And another area I think where we've seen a lot of improvements, typically we'd get the prior year's crash data around the April-May time period. If we go back historically, 20 years ago, it would take, a year or more. So you're working with older data. And that same thing is true to a lesser extent when we look at some of the federal databases, like the Fatality Analysis Reporting System or FARS database. Oftentimes that lags up to nearly a year or so, and the same is true with some of those other federal databases, just because it takes some time to get those data processed. But it has been becoming available significantly sooner historically as well. And so this is what the crash report form looks like. This is the paper-based form, obviously, but the electronic form is essentially analogous to it. So the top section is just general information that describes where the crash had occurred, any specific circumstances, so crash type, the worst injury in the crash, the county where it occurred, the city, date, time, whether there was a work zone in place, whether various other special conditions were met as a consequence of that. Roadway information. So we have linear referencing systems here. And so we'll have a primary road on which the crash occurred. And then we'll provide a distance to the nearest cross street or other reference point. So then these can all be integrated geospatially. General information that describes that roadway environment, and that would include the speed limit, the type of road, and there's several different classifications that are used there. Driver information. So a lot of this wouldn't be directly available to us unless we had special privileges as per a research project, but they would, general information, we wouldn't get date of birth, but we would get age as an example. We would get access to sex of the driver or occupant, type of motor vehicle, license type, presence of endorsement. We would get whether they were restrained, their seating position, whether an airbag deployed. So this is capturing both information about the driver and about the vehicle, as well as the sequence of events that culminated in that crash occurring. And so you'll notice here it allows up to a sequence of 4 events that precipitated that crash occurring. And then below that, vehicle information. This is another section where we really don't get a lot of detailed information, but we get general info about where the damage occurred, how severe the damage was. And so those are a few of the other areas where that might be of interest to NHTSA or even to auto manufacturers in terms of what types of damage are occurring to those vehicles. Now, again, a lot of that information is also collected by insurance companies who make use of that. We can get access to make and model. I don't remember if we get that by default in the extract that we get generally. But like I said, we do have the capability, though we typically haven't done this for our studies, to go as far as VIN number to get very detailed features about all those different technologies that are installed on the vehicle. And then lastly, any passengers in the vehicle as well, and there'll be subsequent follow-up sheets there as well. So the back side of the form is just if you have additional vehicles, additional drivers, and so forth. There's a bottom section that collects more detailed information with respect to truck and bus drivers. So I'd indicated earlier, we have, generally speaking, higher levels of regulation within that specific industry. And then lastly, we've got the crash diagram on here as well. Okay. And so I guess I've already kind of talked through these. This was just basically reviewing what information is included in each of those respective fields. So since I've already talked through them, we'll just skip ahead. These guides are coming straight out of one of the UD10 manuals. I've got a link coming up for these on some subsequent slides here, but it basically goes through and helps you to decipher the codes for each of those respective categories. So I'm trying to remember. I guess neither of you would probably be getting the crash data for the purposes of the 849 project, but if you're doing any work with crash reports, there's quite a bit of detailed information that gets captured there. And I guess I didn't realize it had different codes for turkeys and even elk and moose. The fact that they're distinguishing among those is, I guess, somewhat interesting. From our perspective, one of the areas we haven't talked about a lot here that's important on these forms is this roadway area category here. And so generally this is telling us whether it occurred at an intersection or non-intersection location. And if it was at a non-intersection, it's got separate breakouts for freeway versus non-freeway. And so these are interesting for several reasons. So when we do safety analyses, oftentimes it's easy to integrate the data geospatially and assign all the crashes to some roadway segment, but the causative factors are going to be a lot different if that crash is occurring at an intersection versus at a mid-block location that's far from an intersection. And so one of the areas that's useful for us is just using this as a filter to try to get down to the crashes that we're most interested in for specific program or countermeasure types. Work zones, we've seen significant enhancements in the amount of information that's collected as it relates to work zones. And so there are actually a few additional categories beyond what's shown on this key right here. Just in terms of the area of the work zone where it's occurring. So it used to be very generic, just is this a work zone crash, yes or no? And now there's significantly greater specificity that's provided there. In addition to the area type, we have general information about the traffic way, so whether it's one way, two way, divided, undivided, etc. And then as we look at the actions prior to the crash and the sequence of events, there's a lot of really rich information that can be obtained here that helps us to understand the different causative factors to some degree as well. Okay, so we'll start working through this a little bit more over the next few weeks. I'll have you guys get some practice in using the Traffic Crash Facts data query tool, but this hopefully provides us with a nice overview. You'll notice here, a lot of these cases, they can drill down pretty deep on the vehicle side. And so in some of these instances, we're probably not going to have enough that we could do a meaningful analysis of crashes involving concrete mixers, I would suspect, but they do get to quite a extensive level of detail. And then likewise, for the large trucks, they collect very detailed information beyond what you'd see for passenger vehicles, given some of those restrictions and regulations. Okay. And so let me just check my time here real quick. So sorry, we're going a little bit long today, but so these data ultimately are used for a wide variety of different purposes. We've talked a lot about these, but some of the primary areas where these are of interest is both at the state and the federal level, relating back to our highway safety improvement programs we talked about last week. So identifying where problem areas exist, trying to establish goals and metric-based performance measures, Allocating resources. So, oftentimes before a project gets implemented, we'll have to go through a relatively rigorous benefit cost analysis to show a certain either benefit cost ratio, or MDOT has historically used time of return. So they'll select projects that pay off in a shorter time interval, as an example. Tracking progress towards programs, and then supporting development, evaluation, and research, for example. But one big concern that arises here, and we touched on this a little bit previously, is that there's some concerns in terms of uniformity in crash data from state to state. And I talked about the example. So Illinois doesn't collect historically the same amount of data as Michigan and some of the other peer states here. And so that's challenging for several reasons. So oftentimes we are interested in knowing what the effects of different laws or policies or programs are that may vary from state to state. So if we think about things like primary belt use laws versus secondary belt use laws, or if we have states that have either recreational marijuana or medicinal marijuana, or that wouldn't have any marijuana use, where it'd be completely prohibitive. So there are questions like that we can address because states have some inherent differences in terms of these policies. But in order for those comparisons to be meaningful, we really need to make sure we're kind of comparing apples and apples, as the case may be. And so if states have different reporting minimums, that introduces some challenges there. All states are typically using the same 5-point scale to measure injuries. So I think you've probably seen the CABCO scale before, KABCO, where we talk about the level of injury sustained by the occupants. So a lot of those tend to be consistent from state to state, but when we think about the data that tend to be most consistent, it would be traffic fatalities, just because those all have to get reported to FARS. But below that, there's not really any formal mechanism to require states to report certain elements. There are certain data standards that have been introduced in terms of what data the FHWA expects that DOTs and other agencies will collect, and there's some federal rulemaking in terms of what needs to be included in some of these data systems. But ultimately, it can be very difficult to compare across states for various reasons. And so that's just an important point that we should note there. So oftentimes, like we're working on some NCHRP projects right now, and we're trying to collect data from several states that will give us a representative snapshot of what the picture might look like nationally in some of these areas. But if states collect the data in a different manner, if there are other inherent differences, it makes some of these types of comparisons difficult. When you think about other factors like different geographic conditions, topographical conditions, weather conditions from state to state. And so consequently, it can be quite challenging when we try to do those types of comparisons. But that's what a lot of this data is being used for, is just to track progress within and even to a degree across states in some of these areas ultimately. Okay. Now, here in Michigan, again, the UD10 forms are entered into a computerized database that's maintained by the Michigan State Police. That's shared out with MDOT, and MDOT has some additional fields that they develop as a consequence of that. All the fatals are sent to NHTSA, and again, those are cases where the fatality would occur within 30 days of that crash having occurred. And then beyond that, you do have some level of localized data management systems. The MDOT has a pretty good database, but that's specific only to the state trunk line system. And so counties will often use RoadSoft. I don't know if you guys are familiar with RoadSoft. It's a GIS, it's an asset management system that was developed by Michigan Tech. And so I'd say probably 2/3 of Michigan counties are using that to track their crash data and some other asset inventories. SEMCOG has a really good system that overlays crash data with some of their other asset data and other information sources. But that would vary wildly between cities and counties, generally speaking. And so the most consistent and comprehensive databases are typically maintained by state DOTs. And we'll talk about this more later, but one of the other big examples of why these crash reports are particularly important is they help us to identify where some trends are occurring. And so at this specific location here, you'll notice we've got trends of, it looks like, some head-on left turn crashes. So this might be a location where it would make sense to put in a dedicated left turn lane, for example, or left turn phasing. Looks like we have some similar crashes that are occurring down here near the driveway, some rear end crashes. And so ideally we can use these data to try to identify some correctable issues at these different locations ultimately. And so with that, this is just a link to the instruction manuals and the UD10 guide. So if you've got questions on anything, we can refer back to this. And then I'll start posting some information and some activities that we can use, traffic crash facts, to get at least some familiarity with how these data systems are structured ultimately. So I think that wraps up what I have for today. So when we come back next week, so I'll probably post some supplementary materials in the next day or two, and then we'll come back next week and start talking about the other types of data that we want to integrate with the crash data for purposes of a holistic safety analysis ultimately. Okay, so that wraps up what I had on my end. Do either of you have questions on anything? Okay, great. So like I said, I'll be posting some details about what I'm expecting for the course project, and then I'll also get some information. And again, that project is basically helping to develop some materials that'll be used for subsequent offerings. And then secondly, the second assignment should be posted sometime later this week as well. So I'll keep you both posted on that, and we'll be in touch, okay?